So we look into the normal time, crash time, and crash cost in order to determine the activities to shorten. Okay, so these are the jargons or parameters that we use in shortening activities. The normal time is the low cost, realistic, efficient methods for completing the activity under normal condition. What is crash time? Crash time is the shortest possible time an activity can realistically be completed in. Okay, the shortest possible time, because the shortening activity is called crashing, so the shortest possible time is called crash time. Whereby the crash cost is the direct cost for completing activity in its crash time. Okay, so we have activity cost here. Example, cost duration graph for an activity. We have an activity cost here. We have activity duration here. We have normal cost here, whereby we finish at normal time. We have crash cost here to finish at the earliest crash point. Okay, okay. This is our crash time, which is 5, and normal time is 10. Okay, so this is a crash point, and this is a normal point. So with less time, we increase the cost. Okay, more time, we reduce the cost. Normal cost is 400. If we want to reduce the time to 5 units, then the crash cost will become 800. Okay, so how do we calculate that? Okay, this is a crash point represent the maximum time an activity can be reduced. Okay, the heavy line connecting the normal and crash points represent slopes. Okay, which assume the cost of reducing the time of the activity is constant per unit time. Okay, linear. Okay, the assumptions underlying the use of this graph is as follow. Okay, that is the cost time relationship is linear. Normal time assume low cost, efficient methods to complete an activity. Crash time represents a limit, the greatest time reduction possible under realistic condition. Slope will represent the cost per unit time. All acceleration must occur within the normal and crash time. Okay. Y-axis and the run x-axis. The y-axis is the cost, the x-axis is the duration. So the cost slope is calculated by taking the rise over run, which is the crash cost take away with the normal cost and normal time take away with the crash time. So you will have the cost sloped. So we can see here the slope of the cost is $80 for each time unit the activity is reduced. Okay, so every time the unit activity is reduced, it will be increased by $80. Okay, so comparison of the slope of all critical activity allow us to determine the activities to shorten to minimize total direct cost. Okay, how steep or how not steep the slope is. Okay, there are some priority rules. There are many possible rules for assigning preference to some activities over others when allocating scarce resources. Okay, what we do when we allocate the scarce resources. Most popular project management software packages have a limited number of rules. Okay, that can be automatically applied to level over allocated resources. Okay. Normally, these rules are applied manually. Okay. So, the priority rules of assigning scarce resources. It is as soon as possible. This is the standard rule in scheduling. Activities are scheduled to start on their earliest estimated times, and resources are made available with that in mind. Minimum slack first. Tasks are supplied with the resources in inverse order of their slacks. These rules usually minimize the number of late activities, means that the critical activities are done first, okay, as late as possible. With this rule, resources are made available so that the activities start on their latest finished date, whenever possible, without increasing the project duration. Sorry, latest start, okay, whenever possible, without increasing the project duration. This may seem irrational, but it preserves the firm's resources and delay cash outflows as long as possible. Okay. Shortest task duration first, or most successes, most critical followers, most resources first. These are some of the activities that can be applied when allocating scarce resources. Okay. And addition to these rules, there are many others. For example, it may be company policy to put favored customer. We choose the customer first in order to run the project. Okay. The same type of favoritism is sometimes shown to specific projects of high value to the parent firm. Okay. Right. So we come to the finish of our chapter. So for as a conclusion of this chapter, I need you to summarize this chapter in a short paragraph, not more than one page. Conclusion for this resource scheduling because of time constraint or resource constraints. Okay, submit it together with the other assignment. Okay, I need an individual opinion. Thank you.